people have fear, successful people have doubts, successful people have worries. They just don't let these feelings stop them. Everyone, welcome back, everyone. It's a great pleasure to meet you all again. I hope everyone is doing well. As you know already, we have seen a lot about the physical and chemical properties of the metals. But did we ever think about how we got the metals in the first place? So I am putting this question to you. How do you think we get metals? We are going to find the answer for that really soon. So let's dive again into the world of chemistry to find out the answers. Hello guys, I am the chemistry wizard. I was told that you had a question to ask me. Am I right? So what was it? Oh, the metals. Right? I have a magic book which tells you all about that. So, where did I keep it? I have found it. Here it is. It's called the Book of Extraction of Metals. There are different magical methods which are used to extract different metals in this book.
Magic!
Now, I'm going to take you all to my magical laboratory using my magical word sodium chloride. Do you want to learn my magical methods? I think I can teach you. But you have to listen very carefully. Okay? Then are you ready for it? Here we go. First, we are going to classify the metals into 3 categories based on a very secret criterion. You want to know what it is? Really? Okay, I'll tell you then. It's called the reactivity. What? You already know about it? Really? Then you know about the reactivity series too? Oh, you guys are really smart. Okay then, here is the secret reactivity series. As I already told you, we are categorizing it into 3 based on the reactivity. 1. Highly reactive metals. 2. Metals with medium reactivity. 3. Metals with low reactivity. We'll see about them in detail later. Coming back to your question, metals are found on the surface of the earth. Really? Yes, they are. They may be buried into the earth's crust or may be present deep inside the seabed. They can be mined by miners from there. But do they occur in the pure form? I hope your chemistry teacher has taught you about pure substances. Some metals occur in the pure form. Example, metals with low reactivity such as gold, platinum. But what about the others? The other metals occur with some impurities called sulfides, oxides and carbonates. Now we are going to learn this from my magic book. That how we'll get the pure metal from the impurities. Now, the metals which contain impurities are called minerals. But know this, we can't get pure metals from all the minerals. There is a certain kind of special mineral called ore. This ore has a definition too. Yeah, here it is. An ore is a mineral from which a metal can be extracted efficiently and as well as economically. For example, let's take China clay with formula Al2O3.SiO2.2H2O. It's a mineral of aluminium. On the other hand, bauxite Al2O3NH2O is also a mineral of aluminium. But it is possible for us to extract pure aluminium from bauxite. Anyway, an extraction from China clay will not be a profitable one. So, all ores are minerals, but all minerals are not ores. Hence, the mineral bauxite is an ore of aluminium, while China clay is not. For example, gold Silver, platinum and copper are found in the free state. Copper and silver are also found in the combined state as the sulfide or oxide was. The metals at the top of the reactivity series like sodium, potassium, calcium, magnesium and aluminium are so reactive that they are never found in nature as free elements. The metals in the middle of the activity series such as zinc, iron, lead are moderately reactive. They are found in the earth crust mainly as oxides, sulfides or carbonates. You will find that the ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on the earth. Thus, on the basis of the reactivity, several steps are obtained in the extraction of pure metal from ores. A summary of the steps is given in the next slide. Let's move on to the next topic, enrichment of ores. Now, these ores, when mined from the earth, contain impurities such as soil, sand, etc., which are collectively called as ganns. First, the impurities must be removed from the ore before we start the magical extraction of the metals. First, let's see the methods of extracting metals with low reactivity. Let's take mercury and copper for example. The ore of mercury is called cinnabar with the formula HgS. The ore of copper is called copper glans with the formula Cu2S. We can extract the metals by heating them in the presence of oxygen. Let's see cinnabar first. First, the cinnabar is oxidized into mercury oxide. Then the mercury oxide is reduced to mercury. Now, you're going to find out the equations for extraction of copper from copper glans on your own. Moving on to extracting metals which are present in the middle of the reactivity series, they are zinc, iron, copper and lead. They usually occur as sulfides or carbonates. Note that it is easier to extract oxide ores rather than its extraction of sulfides and carbonate ores. These are the important processes which take place during the extraction. The sulfide ores converted into respective oxides by strongly heating them in the presence of excess of air. This is called roasting. The carbonate ores are converted into their oxides by strongly heating them in the presence of a limited air. This process is called calcination. Let's take zinc for example. Two ores of zinc are zinc blende and calamine. Zinc blende formula is ZnS and calamine formula is ZnCO3. Since Zn is a sulfide ore, we are going to roast it. Here, zinc blende is heated in the presence of excess of oxygen. Therefore, it is converted into zinc oxide. And as calamine is a carbonate ore, it's going to get calcinated. Here, calamine is heated with limited supply of oxygen and it is converted into zinc oxide. Now, the zinc oxide obtained from the above reactions can be reduced using carbon. Zinc oxide plus carbon gives zinc plus carbon monoxide. We have already seen this reaction in the first chapter. These oxides can also be reduced by displacement reaction. I hope you can identify the displacement reactions in the above equations. Now, finally coming to the highly reactive metals such as sodium, magnesium, calcium, aluminium, etc. These metals cannot be reduced by using carbon since they attract the oxygen more than carbon does. So, they can be purified by the process of electrolysis of these molten chlorides. Now, let's see what electrolysis is. It's nothing but chemical reaction which needs a little experimental setup. Many of you had your doubts about this topic. So, I'm going to make this clear to you. Come on. Let's see the things we need. A battery, 2 metal rods, a beaker, an electrolytic solution, an impure metal. An electrolytic solution is nothing but a salt solution which conducts electricity. Salt water is an example of an electrolytic solution. Okay, then let's start. Then let's set these things up. Sodium chloride. See that the two rods are connected to the two ends of the batteries. One rod is positive and the other is negative. The positive one is called the anode and the negative one is cathode. When a metal chloride such as sodium chloride is kept in the solution, it dissociates into Na plus and Cl minus ions. Now the Cl minus ions will be attracted towards the anode and the Na plus ions will be collected at the cathode. Now let's see about electrolytic refining. Come on, let's see about electrolytic refining. Now the metals obtained by these methods may contain some impurities still. These impurities can be removed by using electrolytic refining. This is similar to the electrolysis which we have seen earlier. But there is only one difference. Instead of using the metal rods as cathode and anode, we are going to use the pure metal as cathode and the impure metal as the anode. And the solution of the metal salt is used as the electrolytic solution. Now, on passing the electric current, the metal from the anode gets dissolved in the electrolytic solution and an equivalent amount of the metal is deposited on the cathode from the electrolytic solution. And the impurities get collected below the anode and are known as anode mud. Now, let's take copper for example. In the cathode, we'll have a pure strip of copper and a strip of impure copper as the anode and copper sulfate as the electrolytic solution. Now we pass the electric current. The copper from the impure copper strip, that is anode, dissolve into the copper sulfate solution and an equal amount of copper from the copper sulfate solution gets deposited at the pure copper strip at the cathode, and this process continues till all the pure copper is collected at the cathode and the insoluble impurities get deposited as anode mud. Now we are coming to the last topic of corrosion and its prevention. Corrosion is nothing but formation of oxide layer on the surface of the metal. Now this can be prevented by certain preventive methods like galvanization, alloying. First, let's see what galvanization is. Galvanization is the process of coating iron or steel using a layer of zinc. The galvanized metal is protected against rusting even after its protective zinc layer is broken. Do you know why? Find it out for yourself and send it to me. Last one is alloying. Alloying is the process of mixing a metal with another metal or non-metal in their molten states in definite proportions. And later they are cooled. This highly improves the properties of the metals. For example, iron is the metal which is most widely used. Do you know that iron is not used in its pure form, but it's rather mixed with carbon, nickel or chromium to form stainless steel, which is a very efficient metal which does not corrode at all. Isn't that super cool? There are many other alloys in your textbook. Learn about them and send your notes to your chemistry teacher. Okay, bye guys. Chemistry Whiz is signing off. I am sending you back to your chemistry teacher. We'll meet again. Sodium chloride. Welcome back guys. Hope that you understood what the wizard taught you. I'll be waiting for your notes and answers to the questions which the chemistry whiz has asked you. And please leave a comment about this video and tell me if you understood the lesson. We'll meet again soon in your next chapter. We'll meet again soon in our next chapter. Until then, bye from your Esther Miss. Bye.